In this session, I want to show you about how to create a short protection or break wall. I want to show you the construction. This is typical of the shore protection. The top side, the left and the right side. This is the bottom side. Consists of some different material for the shore protection. This is common happen in construction that we want to build some new island, and mostly in the country. But it happened to in Indonesia, in Jakarta, or in Singapore, and in other country that they want to build new city in the top of the sea level. For the complete construction and the calculation of the quantity, we can create by Civil3D. We have some typical. We have some tree of types to solve this problem. I want to show you how to make it. To create or build shore protection, we have three ways to solve the problem by Civil3D. First is by general assembly. General assembly is we can get in menu section. Then go to general. I want to show you this one. The corridor, create assembly tool palette. Then go to the general. There are so many links to do. Create one by one. This one, link offset elevation, link offset and slope, link offset on surface. Okay. This one, I'll show you. This is the typical, and create one by link slope, link width and slope, link width and slope, link slope to surface, link slope to surface. Okay, let me explain. The next, we can do by grading. Next is we can get by subassembly composer. Assembly composer. When we create by the grading, we can use this one. Grading, click grading. We have a grade to distance, grade to elevation, relative elevation, grade to surface. This one you can create by grading one by one. Grade to distance, grade to slope, elevation, grade to surface, grade to distance again, grade to distance again. We can repeat some command in here. Have advantage and disadvantage by the action that we already taken. Okay, by the grading, it will be damaged in here because this is grade to surface. So I want to after grade to surface, they have some irregular elevation. So after this get irregular elevation, time we have a hang or like when we create the grade to elevation. Okay, the disadvantage for the using the general assembly is when we create the volume in here to here to here, we need to so many codes to build it, and then we can calculate by the artwork looks like per work in here one, in here one time, and here one time, and the bottom line one time. It's too many steps to create that one. Okay. The other one is by the subassembly composer. This calculate the. This is the some easier way to the quantity, but usually we need to understand the basic of the operational of Civil3D first before go to the subassembly composer. Let me begin, and then I want to explain you how our building. One. This is our building. This is the hang, the mental. This is looks like not so exactly like this, and this is this one is need to surface. This is the surface. The second surface, so number 2, already leading, and this one is surface. Okay, this one is original surface. So for this one, we need to like this. In subassembly composer, example, we have built like this. Need to stop in surface, then create some additional in here to here and to here. We have only one to this one. So this okay. Okay. The construction is looks like this one. And the next step we need to make calculation in area for the area and in this area. So we have 4 different material. Typically, I prefer for the left hand side. I think it's same. What we need to know in the detail. Okay, so what we're gonna do is open the Subassembly composer. You can access by the window and go to Autodesk. Click here. This is the Subassembly composer. This is the location to create the new point. This is the viewer. This is the properties to edit and modification. To know. This is the action we want to do to create Subassembly composer. This is looks like the center line. Then we go to point and drag it down under the start. This is for action. No need to take more action. We just go to the next level. This is the point number 2. Okay, this is the one. Usually, and the assembly, it's like the center line. Then the action number 2 is we can create on the other side, other side, starting from the P1. This is the point number 2, but start from point number 1. So I want to show, okay, which one we want to build is in here. I want to show you the, we want to build start from here, so we already have the dimension. Here to 0.71, okay, without super elevation, because this building is not for the root construction, but for protection. No need to create some super elevation. 0.72. On the left side, it means we have a delta X and delta Y. We can use the delta X and delta Y in here. Delta X and delta Y. Delta X. Before we go to the left side or right side, we have to input and output and the target parameter. This parameter, target is surface or target is offset. I will show you this is offset. And then grid is 1 meter. Target setting. Then go to the input parameter, grid parameter, side, this side, left or right. All right. So in this column, we already arranged the target parameter and input/output parameter. Next, go to this point, and we have a delta X and delta Y from point P1, and delta X is 0.1. Or we can create a code in here with input this left side, left, then offset with with 1. Okay, this 0. Okay, I want to typing 2 in here, so I copy this command to here, delta X in here, then delta Y is 0. So we need to know this one. This is P1, this is P2, this is Y in 2 meters, and then delta Y is 0 and flat. Then go to the left from the center line, go to the left. If I change 1, this one will be stretching. Okay, I need 0.21. So from here we can easily to modify. If we just type the number in here, 0.271, will be rigid, so we can manage after we change something. Better to use a parameter like this. Okay, I want to change with left 1. Okay, already change in here too. Okay, the next step is another point. Okay, this one I want to build this one first, from here to here, and go to down, go to surface. I want to make line. All right. Okay, this is one step. I already get on the top, and then I want to go another from this one, enter, and this one. .5 by 1. This is horizontal slope 1.5 by 1. Go to the subassembly composer again, go to the point, and the next point is from P2. It's from P2, but the execution is the point geometric type is slope to surface. And then I create the parameter. The parameter number 2 is slopes with S. Okay, sorry. Slope with S. Okay, and this is the grid, and 0.776, or we can create 2 by 1. 2%, it means 200, it means 50. 2 by 1, it means 50, and then 4 by 1, it means 25. Okay, for the next step, I want to create the target parameter. This is create EG, create the parameter, and target parameter, it's EG. EG is existing ground, go to surface, preview value is 1. And for the target parameter, I want to copy this one, copy the EG, then go to point number 3, start from point number 2, and slope to surface, target parameter EG. Okay, this one, EG, we can test the EG one, the EG is 1, 0.2. Okay, this is target, so the surface we can adjust by manually. This is as helping to view the real action. We can make it on the Civil3D. If I click here, the EG will be go up. It will be error, and when I drag and drop in the level under the P1, the slope will be under the P1. This one is slope is already go to surface. Before we preview have in here, but on the slope there is minus %, so we can change, enter. This is the plus, and in target parameter we have the plus 0.09. This is only for the viewer in here. In the Civil3D will be more flexible. If I adjust again, go to down, in here there will be no P number 3. Okay, I want to make a minus 0.5, then go to the P number T and go to input output parameter minus, it will be fine again. Okay, and the next we go to, we already have this one, this line, this point to this point, and we this line to another line, and I want to get this line here to here, which is we have the distance one. Go to the next point. This mostly common, this is usually the regular. From the P4 we start from the P3 and slope and delta y. We took screen in here, sorry, delta x and delta y. Okay, this is we have in here this one with left 0. With left 1 0.27, and we can copy, create parameter again, and Control C to create this one. Number 2, we put 1.5. Then I can copy this one to number 4 and delta x. Enter. It's running like this. From this PP4, okay, this is automatically link, and we can make it off link by click this one, on and off. We want to check again this one. This is 0.9, 0.5, 0.590. With the height is 0.90. It means 1 by 1. go to point number 5. This is point number 5. It's come from number 4, but it's come from number 4, and then I use slope and delta y. Slope 100%. Okay, slope this one. Slope to serve 100%. I slope 2, slope n. Slope to n. I create a grid and I create the 100. It means 1 by 1. Slope to n. I put the copy for this one. Slope to, and delta y is delta y. It's a width of n. Grid parameter. I put width of n. Width of h. .59. I'm going to copy this one to this one. Flip the screen. Okay, this is when I create this one to this one. When I create 0.19, go to this one. Okay. Next, I want to create the point number 2. Point number 2. Point after number 2. The point higher E2. I mean this one. This is point number 1 on here. So I want to create 0.9 in here. To screen, point this one. And I start from P1, and delta y, but I want to create a delta y by type number 1 or depth number 1. Depth, create parameter depth material depth 1 and 0.59. Copy this depth 1 to delta y in here. Okay, so I want to see this one already mentioned. Then I want to go to this one. This is 0.71 plus. Looks like different. Okay, start from here. Okay, after we have 1 point on the top in over P1 and go to the point, another point over P2. I want to create point in here. Then I want to start from the P. Which one? This is the P5. Okay, and then I want to use delta H and delta y. For delta H, I want to check the delta H. I want to check this one, P2 is called the width left. Then I want to go with width left number 1. Copy and delta y. Width left number 1. Sorry, this one. It's from P6. Sorry, this is from P6 in here. And then we need more additional again to adjust. This is usually we have adjusted to create the type of the construction. This top is more wide to the left, so the depth of the construction will be more high. So I wanna put code. So I want to put code in here with the add grid parameter with left grid parameter, and then I put here with additional and 0.271. Okay, let me see to make sure. 0.172, 0.172. All right, with additional. So I want to copy this one to this one. Plus Ctrl V, enter. Okay, so this for it consists of width left number 1 plus width additional. So on the Civil3D we can see only type some additional only, because this is already exactly by the width left number 1. Then we want to go to the over P2, over P3 to here, and then I want to put from the point number 7 slope and delta y. So wait a moment, I want to erase this one first. Next, make a point in here, but I need to additional width from this one. With the depth, I put by code 0.59. So go in here, and then I create the new point, start from point 7, that one, and I have a slope and delta y. Okay, now I need to from P number 3 from here. Okay, I want to delta x and delta y, and then delta x I use the depth, copy in here, delta y. Sorry. Okay, this one. But I need to delta x by flexible criteria, so I need to create the new parameter number 1 with additional number 2, this one. Okay, then I copy this with additional this x, then I adjust the 0.1789, 0.1786, 0.1786. Okay, right, but I don't want to add some link this here. Then I go to link in here. My link is start from P7 to P8, P7 to P8, this one. Then I get another point over P4. I want to make sure this position of P4 is strike on the top. Okay, this is, I want to make a point, strike over the top P4 in here. Then I start from P4, delta x and delta y. The delta y I use its sim, and then delta x I put 0. Then I create new line in here from P8 to P9 and from P9 to P5. Line number 1 is from P8 to P9. Line number 2 is, okay, I need to make go to slide first. Okay, this one, I create this one. P9 to P5, P9 to P5. Okay, like this one. Hit the screen. So we have the construct. We have a building that already adjusted elevation by the existing ground level. But for calculation of the quantity, we need to check one by one the code in here and add shape code to create a volume as material. Okay. Then how to calculate the calculation of quantity? I want to show you this one. Create shape over here. Okay, shape after S1. Add link, you can shape code is AR. Then we can choose which link already created, which link to create this shape. Just click in here, then right click. There's something problem in here. Here, you need to do apostrophe this one. Enter. Okay, good. And how we can load to the Civil 3D? This is the way. It's closing. I will copy in here. And I delete this all material. Okay, how we can import the subassembly composer to new Civil 3D? We have this one. We can right click in here, then okay, sure. In here, the import. Okay, wait a moment. I need to make some name. The name is we can create in here. This is not subassembly one, but I need sure protect left. Okay, and I just save as it's already in. And the bahan training the composer source number 1 PKD. Then I just load it on the Civil 3D. Right click in here, import subassembly. Go to here, and then go to my document. Bahan training assembly composer source to palette source. Okay, this one, and I put in here. On the left side, right click. Some parameter with left number 2. With left number 2, just it will be start moving in here. Back to 1.5. This is the assembly, still not a so okay, set all target, here to set line okay. Okay, it's working in here on the left side. So the calculation we want to delete by the section, and then compute material. Okay, we delete this one. Then this is not the quantity, but this is the code because we already put the shape here, so already create some model and style. We can change by this one section basic, go to the without or with the hatching, and change this one. Now it's already clear. Then if we want to know the quantity, just go to the corridor, then go to the section compute material. Okay, need a new material, add new material. We create AR left, enter, then we change with the structure. This is use corridor shape. We have corridor A1 AAER. This is the name of corridor. AR is the name of shape. Then just put in here. You can change the style. Concrete heads is okay. Gravel is okay. We can modify the area in here. Go to the section. Solid we can change by the other style. Careful. Okay. And then we change to 0.2 like this one, like this one, like this one. Section, and then at table material volume we find out in here AL life. Okay, this is perfect. I think this the last better way to create the construction, unless we use the assembly normal assembly by generic, or second way by using the grading. This is a tutorial, so you need to follow the instruction step by step. Thank you. Bye bye.